Hi dosto, in this series of dynamic programming, today we are going to solve 0-1 knapsack. Lekin one thing, we are not going to do like the people who just start making the table. वो 3 idiots का चतुर होता है ना अपना कि उसी की तरह बस table बना दी and start filling the table towards the end. This is our answer and boom. Nah, we are not going to do that. We are going to approach this question rancho ki tarah ekdam. Like we are going to know that how people come up with this idea of the table, or how we should fill the table with wide top down approach, and how they come up with the idea of this storing the values. So we'll trace the journey all the way from recursion. Yes, you got it. All the way from recursion to memoization, all the way up to top down approach. So without wasting time, let's get started. So very first thing, 0-1 knapsack. What is the meaning of 0-1 knapsack? I mean, knapsack, okay, you guys know it's a bag, but what about 0-1? Why there is a 0-1? Well, 0-1 denotes that you cannot break the item that we have into two pieces. So either you can take the item 1 or you cannot take the item 0. So basically you are a person who has a knapsack bag and there are n items. ... Okay, so we have n items. Now you want to put those items into the bag such that you want to make the maximum profit. I mean, okay, one obvious thing is you will be like, why don't you put all the items into the bag? Well, that's not possible because there is a capacity W of a bag which shouldn't be exceeded when you're putting the items, and each and every item has a weight associated with it. Cool, chalo problem statement पढ़ लेते हैं. Given weights and values of n items, put these items in a knapsack of capacity W to get the maximum total value in the knapsack. In other words, given two integer arrays well and weight which represent values and weights associated with n items respectively, also given an integer W which represents knapsack capacity, find out the maximum value subset well such that the sum of the weights of the subset is smaller than or equal to W. Okay, so थोड़ा सा क्वेश्चन लैंग्वेज समझ लेते क्या कह रहा है, ठीक है. सो इफ यू आस्क मी व्हाट इट इज सेइंग. अच्छा, एक मिनट समझने से पहले यू गाइज बी वंडरिंग व्हाट आर द एप्लीकेशन ऑफ 0-1 knapsack. आई मीन ये थीफ, चोर, व्हाट्स द रिलेशन विद कंप्यूटर साइंस सॉफ्टवेयर, लाइक क्या हो क्या रहा है. ओके, लेट मी गिव यू वन ऑफ द एग्जांपल. इफ यू वांट अ रियल लाइफ एग्जांपल, then there is like internet download manager. So what it does, it has to send the data from, like server has to send some data, and the data is available in chunks and packets, so of different sizes. So it want to make sure the window that it is sending, to maximize that window, a lot of server uses this algorithm 0-1 knapsack. Fail नहीं आया? अच्छा चलो एक रियल लाइफ एग्जांपल, रिलेटेबल एग्जांपल लेता हूँ. So just before the exam, like a night before the exam, you guys have 10 hours left. सबका ही होता है, कोर्स तो खूब सारा बचा होता है, राइट? तो अब इतना सारा कोर्स बचा है, you have to do like 10 different chapters and like time left is like some 10 hours or something. Now what do you guys do? Tell me, what do you guys do? You make a chart in which you write the chapter name, then the marks, it usually in examination paper, that what is the weightage of that particular chapter and how many time it's going to, like how much time it's going to take when you are going to read the chapter or when you're going to learn the chapter. तो उसमें जो वो time left है ना 10 hours, that's your knapsack bag. ठीक है, तो 10 घंटे का तुम्हारे पास बैग है. Now each and every chapter denotes an item. ठीक है, an item which is available, and you know the time it's going to take. Let's say one chapter is going to take 3 hours and it's going to give you like 40 marks. So you will just be right away into that particular chapter first. So जो marks है वो हो गया तुम्हारा value, and the time it's going to take is the weight of that item. Now you want to do maximum what? Chapters? No, you want to score maximum marks. Similarly, you want to find out the maximum profit. Okay, so let's try to understand the same thing. So the thing that I'm saying 10 hours is left. It's basically W, a variable which have the knapsack capacity. Then you will have different items. So I'll just write items or our chapters. So we'll have item 1, 2, 3, ... Now each item, each chapter is associated with time and the marks you are going to get if you do the chapter well. Acha. So the thing is, the first is the time. So the time is just like the weight of each item. Let's say first item is 30 kg, then some 20 kg, 10 kg, and the marks. So marks is basically nothing, a value array, so which is going to be 300, 200, or let's say 150. And you have some capacity, it can be anything. Let's say you have a capacity of 400 or 450 kg. So you would like to make the maximum score. Here you can easily see that we would like to take our item number 1 and item number 3. Okay, thoda sa teda ho gaya. I hope you understood. So this is what 01 knapsack. Now without wasting time, let's start our dynamic programming ka safar. Achha, if you guys know, the very first thing that we need to do when we are doing a dynamic programming question is to find a recurrence relation. So if you don't know, I have explained all those things in the previous video. You can check that. So we need to make our recursion diagram or our selection diagram. ठीक है? तो वो किससे बनता है? It basically you convert the language of the question into a diagrammatic diagram. So एक diagram के way में अपन question की language को change करेंगे. आइए देखते हैं. So the very first thing is that the sum of the weight of this subset is smaller than or equal to W. So what does this denote? Suppose we have an item Wi. Okay. So it says it should be smaller than or equal to the capacity of your knapsack bag. As simple as that. Now if that is true, then what do you want to do? You want to find the maximum value. Okay, we want to find the maximum value. So I'll write max value. From which? Whether we should include that item or whether we shouldn't include that item. So max value that we get from either including the item or not including the item or including the item. Okay, I hope you understood. So I'll repeat it if not. So you have a Wi, the weight of some ith item, and now the weight of that item is less than or equal to the knapsack bag. Now you have an option. You can include that item in your bag, or you can not, you may not wish to include that item because it's going to give you less profit. So out of those both the things, whatever the maximum value we are going to get, that will be as our answer for that particular item. Now the other option is, what if this is false? What is the weight of the item is greater than the weight of knapsack bag? फिर तो include ही नहीं कर सकते. That's it. We cannot include that item and we will move ahead for like checking the next item whether we can include it or not, or how we can generate the maximum profit. Okay. Okay, the next step in dynamic programming is, once you have drawn your selection diagram, is to write a recurrence relation from that particular selection diagram. So just look at your diagram. The first condition is Wi is less than equal to W. Achha. There is one thing that we need to find when we are doing this recurrence relation. Recurrence relation, a mathematical sequence of a function which recursively call itself. So, just like you used to have f of x and everything in your 10th standard or whatever class. So similarly, I'll just write the function f. Now x was something, a variable which keep changing. Okay. So what are the variable parameters that are changing? So the very first thing is the ith item. Okay. So ith item ko include kare ya nahi. So, or on which item we are talking about. It can be first item, second item, third item, fourth, any item. So our first variable will be I. What is the next variable? Let's look at it. So what if I select this item Wi? We are talking about, let's say we have a 2 kg of an item and a bag capacity is 10 kg. Now if I include this item, then the remaining capacity of the bag will be 10 minus 2, which will be 8 kg. So the next variable parameter we have the weight of the knapsack bag. Acha, usually what happen is like, कुछ लोग को confusion होता है कि why not profit? When we are including the item, then a profit is increasing. So why not profit is a variable? Well, profit that you're going to make is basically your answer. To make it more clear, if you guys have seen this 2D geometry, so 2D geometry में क्या होता है कि there is a point. Let's say, okay, I'll just draw a line, and now if we want to find the shortest distance from the origin to that particular line, then what you're going to do, you're going to move across this line. So what are the variables that are going to change? X and Y, right? As well as the distance. But distance is the answer, right? So first you calculate X and Y, and distance can be calculated by using the formula X square plus Y square. Okay, so similarly, just like the distance is the answer, a profit is the answer, and the variables that are changing are the one which results in that particular answer. Okay, so this thing is clear. Now, what are the next thing? Let's look at a diagram. A diagram says if W of I is less than equal to W. Now, if that is false, then we will not include this particular item. So that means if, let's just say, our W of I is greater than W. Now, if that is the case, then we'll move towards the next item. Okay, so suppose if this was our array of item, and right now if our I was here, then we'll move towards our next item. Okay, so let's say I minus 1, and the next thing is W. W will remain the same because we haven't included that answer, or sorry, that we haven't included that particular item in our bag. Okay, now what is the next condition? If it is less than equal to, if that thing is true, then maximum. So that means if this condition is false, then we would like to find the max value of what? Whether we include this item or whether we don't include this item. Okay, so if we don't include that particular item, then we'll simply move to the next item, and our weight will remain the same. But what if we include this item? If we include this item, then you will get the profit that we are generating from this item, plus you will check the rest items and your rest weight. Acha, should I write W here? Should I write W? No, I mean you shouldn't write W here because now your capacity has been reduced by the weight of that particular item. Okay, if that thing is not visible to you, whatever I've written, I'll just write it here. So that will be well of your ith item plus your function I minus 1 and W minus Wt of I. Okay, I hope this thing is visible to you. Why is that? Because if your capacity was 10 kg and if you have included a 2 kg of item, then you are left with 8 kg. So that's what, if you are including this item, then we are going to reduce the weight. Okay, now let's code this recursive function that we have right now written. So we have written a recurrence relation, and all we have to do, we have to code it. Okay, so let's do it. So दोस्तों, now we are going to recursively code a knapsack function. So for any recursive function, we need three things. The first is a base condition, then a recurrence relation or a selection diagram in dynamic programming, and then finally we return our answer. Okay, so let's code it. So I have named a function as find knapsack, and the following are the parameters. Int I denotes the ith item that we are talking about, and int W denotes the capacity of our knapsack bag, and Wt array is the weight array which is associated with each item, and similarly value array is the value of each item associated with, which is associated to each and every item. Okay, so the very first thing in recursive function is the base condition. So what is a base condition? A base condition is something which basically halts your recursive function or which makes it stop from calling itself recursively. So what are those conditions for a knapsack bag or a knapsack function? So if our I becomes negative, that will mean that there are no items. So I'm using zero based indexing, and if I is negative, then that means there are no items. So the profit that we can make from the remaining item, that is no item, will be obviously zero. Okay, the next thing is, what if the capacity of the bag is zero? I mean, if your capacity of your bag is zero, then obviously you cannot put any item into the bag, and your profit that you can make will also be zero. Okay, so the next thing is a recurrence relation or a selection diagram. So what was the first line of a selection diagram? Well, we were checking whether the weight of the item we are talking about. So what is the weight of the item we are talking about? WTI. So if it is less than equal to the capacity of the knapsack bag, then we may or we may not include it. So I'll just make some space. Okay, so basically this will help us in finding the maximum profit that we can make. So we may include it. So let's include it. So once we include it, then we'll also take the value or the profit that we are going to generate from this ith item. But if we have included this item, then I also need to subtract the weight of the bag. So that will be a W minus WTI. So whatever the weight of this item is, we are taking its value and we are putting in a bag. Then if the capacity of a bag was W, then now it will be W minus WT, and we'll move to the next item. So it's I minus 1. The rest of the thing will remain the same, that is your WT and your val array. Okay, your next option is to not include this item and just simply move towards the next item, so which will be I minus 1. In this case, the capacity of your bag will remain the same because you haven't included it, and your weight and your value array will remain the same. Okay, so this will be one condition. Now the next thing is, what if your weight of your item is greater than the capacity of your bag? Then we cannot include it in our bag. So we can simply find knapsack and we will move to the next item, I minus 1. The capacity of bag will remain W, your weight array and your value array. Okay, so this will be your answer in case if it's less than or equal to W. So I'll simply return this as our answer and this as our answer. That's it, guys. This will be our recursive code that we can generate from our selection diagram within minutes. Okay. Okay, so we have coded it. Now let's see that, I'll try to show you that there are redundant calculation and why we went to a new technique of storing the value. So let's take an example. So we have item 111, item weight as 111 and item price is 232. So we are going to draw a recursion tree for this particular example. Okay, so initially we are on the item number 3, our I, and we have a knapsack bag capacity of W. Okay, so I'll just change the pen color. W is yellow is fine. Okay, so now the next thing is, if we include I, then our I, okay, so this will be your not including and this will be your including. Okay, so now if you are not including this item, then initially if our I was here, your I will move to the next item. Okay, so which will come here. So as you see, your I is reduced by one value, but your W, which was 2, it's still 2. Okay, so now what if we include this particular item? So if we include this item, then what is the weight of the item? The weight of the item is 1 kg. So our knapsack bag capacity is reduced by 1 kg. 2 minus 1, 1. And we move from this third item to our second item. So from 3 to 2. Now similarly, if we doesn't include the particular item, so I'll just make it as ni. So if it doesn't include this particular item, then we'll come on the first item and the capacity will remain 1 kg because we haven't included the item. Now similarly here, instead of not including, if we include it, now if we include this particular item, then we'll reduce the weight of the knapsack bag from the weight of the second item. So we'll just reduce, that is 2. So 2 minus 1 will give you 1 here, and will come from this particular point, this particular item to this item. So from 2 to 1, if this is 1 based indexing, then you will come from 2 to 1, 2 to 1. Now if you see, then this subtree and this subtree is same. So there is a redundant calculation. I mean, you're calculating the same thing again and again. So what you can do, you can store, once you have calculated this particular subtree, then you can store the result, so that when you are recalculating the same state of that particular function, then you can just simply look into that particular table or array wherever you have stored those values, and then you can directly get the answer rather than recalculating the whole subtree again and again. So this leads to what we call as memoization. Spelling बिल्कुल सही है, सुनने में थोड़ी अजीब लगती है, but बिल्कुल सही है spelling. So what is memoization? It's basically when we cache our recursive function, then it is called as memoization. Okay, without wasting time, we have already done our recursion, so let's do it. Okay दोस्तों, now we are going to store the values. So the very first thing is to decide what dimension of array we should take to store the values. So dimension of the array that you're going to use, I'll call it as dp. So its dimension depends upon the parameters, the dynamic parameters that you have. So here we have two I and w as two dynamic parameters, or are two variable parameters which are changing when we are calling the function. So I'll take a 2D array. Now you can initialize a 2D array with the value say 0, and if you're using C++, then you can use a function named memset. So it takes the name of your array and the value with which you want to initialize and the size of the memory block that you have, that you want to initialize. So I'll just simply write into 1000 into 1000. Okay, cool. Now we want to store the result. So how we can store our result? Well, whenever we are returning the answer, we'll just simply write dp of I and w and we'll store it. So we are also calculating our answer in case if the weight of that particular item is greater than the capacity, then this function call is going to return our answer. Okay, so now whenever we are calculating, we are storing that result. But what if we come to the same state again, of which we have already calculated? So we don't want to recalculate it. So what we can do, in case if a dp of I and w, now if it is not equal to 0, that means we have stored some values or we have already calculated that particular state. So we'll return dp of I and w. That's it, my friends. That's all in memoization. So you have stored the parameters, or you have stored the values for the corresponding parameters, and you are stopping your recalculation by checking that if you have already calculated, then you're going to return that particular value. Okay, now let's move ahead. So we have made our recursion efficient. Okay, so the next thing that we would like to do is, I mean, we have saved all the calculation that we were doing twice, so we have made it efficient, no doubt, but still there is a problem. Well, what the problem is, when you use recursive technique, what happens is your stack memory gets filled when you call the function too many times. So if you want to know how it is does, then I've explained in the previous video. Right now we will move forward. So diecut a cyclic graph. The next thing how we can make our function more efficient is, instead of calling in a recursive way, we can do it in an iterative way. Now the thing is, वो जो चतुर वाली बात बोली थी, सीधा लोग जो टेबल बना के शुरू जाते हैं, they just simply make this table and they start filling the table in this fashion. कौन बोला इस टेबल को इस फैशन में करने को? Why there is a need to do? Can't we just directly find out our answer? In order to answer all those questions, let's see the diecut acyclic graph representation of a 0-1 knapsack. So to save the time, I have already calculated for you, or I have already drawn it for you. So we'll see. I'll explain you. These are the items. 0 item means there are no item. Item number 1, item 2, item 3. The weight associated with each item 1, 2 and 3, and the price, that is the profit that you are going to make, 2, 3, 8. Okay. Now we want to find out this, that what does this represent? 3 and 5. 3, 5 represents that you have 3 items, and what does 5 represent? So what is our x-axis? It is knapsack bag weight. So if you have 3 items, these are the 3 items, and if you have 5 kg of weight, then what will be the maximum profit that you are going to make? This is a question. इसको ज़्यादा समझना मत. It's basically like ज़्यादा मत समझना, मतलब इतना टेंशन मत लेना. ये ऐसा समझ लो कि 4th quadrant है, ठीक है? So this is our x-axis and this is our y-axis. So right now we are here. So just like any point which require x and y coordinates, simply I have written the same thing, our x and y coordinate 3, 5. Simple? Okay. So in order to find out this as an answer, we have 2 options for the third item. We may include the item into a bag and we may not, but the very first condition is to check the weight of the item should be less than the weight of what? The knapsack bag, that is 5. So 3 is definitely less than 5, so we have option, we may include it or we may not include it. Now if we include that item in a bag, then the capacity of bag is reduced by how many kgs? 3 kgs. So 5 minus 3 gives you 2 kg. So from 5 kg we are going towards 2 kg. And since we have already included this item and we are done with this item, so we'll check the next item, which is our item number 2. Now, or what we may do, we may not include this item into a bag. Now if we don't include this item into a bag, then our 5 will remain the same, the capacity of a bag, and we'll move towards the next item, that is from 3 to 2. Okay, so now what is the state here if we are on 2 kg and 2 second item? So you may check the very first condition that the weight of that particular item is less than or equal to the knapsack bag capacity, which is true, 2. So we may include this item. Now if we include this item, then we are left with 0 capacity, true. And if we doesn't include this particular item, then a capacity remains the same and we move towards the next item, that is 1. Okay. So similarly, if you see here that if it doesn't include the second item also, so what happens? Your capacity remains the same and your item number, you move from second to 1. Okay. Similarly, if it doesn't include this particular item, that is item number 1, then you will go from this state to 0 item and you will be left with 2 kg. अच्छा, ये जो path है, what does this denote? It denotes that you have included the third item. Then when you're moving vertically, you are not including that item. So you have included the third item, not the second item and not the first item. And if we talk about this particular line, then it represents that you haven't included any particular item. अच्छा, इसका एक और मतलब है जो बहुत important है, वो is in order to calculate this item, you need to calculate first this state. And in order to calculate this state first, you need to calculate this state first. Similarly, this state before it and this state even before it. So let's see. Now I'll just make pen color as yellow. Acha. So in order to calculate this, first you need to calculate this and this. In order to calculate this, first you need to calculate these 2 points. अच्छा, अगर तुम एरो समझ रहे हो तो इतना पता पड़ जाएगा कि this is the point where you have to start your calculation. Okay? If you have calculated this thing and this, then you can calculate this point and this point. So we'll start all the way up from here and finally towards our answer. ठीक है, इसलिए टॉप डाउन अप्रोच आई. अगर रिप्रेजेंटेशन देखो समझ में आता है कि ये एक पॉइंट का कैलकुलेशन जरूरी है अगर इन दोनों पॉइंट की कैलकुलेशन चाहिए. इस पॉइंट की कैलकुलेशन से पहले इन दोनों पॉइंट की कैलकुलेशन चाहिए. इस पॉइंट की कैलकुलेशन से पहले इन दोनों पॉइंट की कैलकुलेशन चाहिए. एंड that's how we do iterative solution. Okay, so without wasting time, let's do our iterative solution. So dosto, once you have coded your recursive function, then it's very easy to convert it into an iterative solution. So here you can take your input in whatever language you are coding. So I'll just tell you what all variables you will need. So one variable to represent the number of items, which is your n, w to represent the capacity of your knapsack bag, then weight n to represent the weight array of your associated with each item, and value n, which is your value of each item. So similarly that we were using like dp to store the values in memoization, will need a 2D array which I'll call as napdp to store the values. Okay, so as we see in diecut graph, we need to use two for loops. So we need to start from left to right and we need to go from top to bottom. So the very first thing that I want you to tell is the item that we are going to see. So we'll go all the way up from I equal to 0, which will represent a 0th item. So I less than equal to our nth item, I plus plus. Now next thing is your, let's say, the weight. So I'll represent weight with the j. So your weight will vary from 0 to the capacity of your knapsack bag. Okay, now we need to see a recursive code. So as you can see, this was a base condition if I less than 0 and w equal 0. Well, here our I could have been like a negative value because we were using a 0 based indexing. But as you see here, we are using 1 based indexing. So we are starting from 0 because we are going to insert the values in a table, and if the index or that we are passing through a table is negative, then you're going to get wrong answers. So we are using 1 based indexing here, just remember that. So if I equal 0, which basically represents that there are no items, or j equal 0, which basically represents the capacity of your bag is 0. Well, in that case, the value that we are going to put will be 0, just like the base condition that we have written here. Okay, so the next thing is we are asking for a condition if weight of that ith element is less than equal to the capacity of your bag. Okay, so we'll do the same. We'll write else if the weight of this ith item. So if it's a second item, then it will be on the index I minus 1. Now if it is less than equal to the capacity of your bag, that is your w. So here w is being represented by j. If that is the case, then your napdp for I and j will be what? Let's see from here. Max of if you are including that item or if you're not including that item. Okay, so I'll just simply write the same thing here, max of. Now whenever you're calling the function, you know that you're going to store that in your napdp. So your find knapsack represent your napdp, or I should say your napdp represent your find knapsack. Okay, so the very first thing is we are assuming that we are taking this item. So I just simply take this item. So this is the profit that we are going to make if we include this item. In this condition, we'll check for the previous item, that is I minus 1, and we'll reduce the weight, which is j minus weight of this item. So as you can see, I've written the same thing, I minus 1, w minus weight of I. So I minus 1, j minus weight of I minus 1. Okay. Okay, so the next option that we have is to not include this item. In that case, it will be simply nep dp. So what we have written here, we have written we'll go to the next item and the capacity of the bag will remain the same. So we'll go to the next item or a previous item and the capacity of your bag will remain the same. Okay. Okay, so now what is the next condition? Well, the next condition is if this is false, then our answer lies in the next item, that is a I minus 1 W. So I'll just write here else. Find knapsack is being represented by nep dp. So for I and j, it's equal to your again nep dp I minus 1 and j is your W in iterative solution. As you can see here, it's the same thing I've written here. Okay. Okay. Once you're done with this double for loop, so you will get your answer stored in the index value of nep dp, which is your nth item or your n items and W weight. That's it. Okay, so we are done. Now, if you have liked this video और तुम्हारे concept थोड़ी strong way हो, then hit a like button, share it with your friends, and also subscribe to the channel. If you have any query, you can ask on my channel, Manvendra Singh Chhajerh. And like before ending this basically video, I would like to thank one particular person. So actually वो जो junior है उसकी वजह से ये सब मैंने notes बनाना शुरू किए थे. I used to teach her and उसका Goldman Sachs के अंदर भी उसका selection हो चुका है. तो उसको बहुत बहुत बधाई Goldman Sachs के अंदर internship के लिए, and she is in just 3rd year. Okay, so it's a very big deal. And उसने जो डाउट्स पूछे थे मुझसे जब मैं उसको ये पढ़ाता था डायनामिक प्रोग्रामिंग, उन्हीं को मैंने नोट डाउन करके रखा था ताकि वही चीज़ें मैं तुमको और क्लियरली बता सकूं. एंड द इम्पॉर्टेंट थिंग इज बेसिकली उसका बर्थडे है आज. सो विश यू अ वेरी हैप्पी बर्थडे एंड तुम्हें लाइफ में काफ़ी सक्सेस मिले और तुम ऐसे ही सक्सेस की सीरीज पे चलते जाओ, मतलब स्टेयर्स पे एक के बाद एक और ऐसे ही सबको प्राउड फील कराते रहो. चलो अब मिलते हैं नेक्स्ट वीडियो के अंदर अपन, जहां पे अपन सेकंड क्वेश्चन करेंगे 01 नैपसैक से रिलेटेड क्वेश्चन. सो क्लास 1 सेकंड वीडियो नेक्स्ट वीडियो के अंदर. अपना चैप्टर तो हो गया यहाँ पे खत्म 01 नैपसैक का. ठीक है, तो मिलते हैं दोस्तों. जय हिंद,